Thank you very much for that introduction. That's lovely. Let me make sure I'm sharing everything I should be sharing. And you should see the presentation there. Is that right? Yeah. And I'm going to just get you back on the side. Okay, brilliant. You got those details already. I'm Dr. Asha Ward. I'm working at the AUB at the moment at the Arts University in Bournemouth, a new kind of creative tech research lab. So we're always looking for collaborations. So please hit me up if you fancy some of that action. You can come and visit us and see what we've got in the innovation studio there. But today I'm going to talk a little bit about my background and then about some of the research that I've done, speaking to what Tom's already told you. So my background is in music and audio technology, where I studied at the Bournemouth Uni in the sunny south down here. And as part of that, I did a placement year. I wanted to be a sound designer for like Star Wars and things like that, but there weren't that many placements in those kind of positions. So I took a placement at the Three Ways School in Bath with a guy called Luke Woodbury as my mentor there. And it's a special educational needs school. And I worked as an interactive designer at the school, which was code for me for making weird bits of tech in the studio. We were sort of in a cupboard in the side of this sensory studio, just making things for people, which I'll talk about now. So this is a picture of the sensory studio. Sorry, it's a bit dark, but we had 180-degree projection. We had 12.1 surround sound. We had bespoke lighting, all controlled by Max MSP. We'd usually give the teachers or facilitators the iPad to control the room, and we'd be making content to engage with the curriculum, basically. And we'd have children from 4 up to 18, from those with mild learning difficulties right through to children with profound and multiple learning and physical difficulties. So we had a whole broad spectrum of kids coming into the studio, and we had to cater the content in there towards the kids that would come in. So we've got a lovely video on Vimeo about the sensory studio. It's such a long time ago now, 2012, 2013. But it just shows some of the things that we did in the studio. So I'll just show a quick clip. Hopefully you don't necessarily need the sound, but the space team, we've got the iPad. So basically the studio, we combined physical, digital props, and we built things. This was the physics term, so they were looking at physics. This was the most popular thing that we ever put in the studio, this interactive floor, and it was camera based from the top and using sort of blob detection to create the ripples, and everybody engaged with that. You know, it was, people could roll over it in their wheelchairs, people would lay on it. Didn't take any explanation. It was really one of the most popular things we did. But that whole video, you can look at that in your own time. It's on Vimeo. So that led me into looking into these types of interactive technology. We use things like the Makey Makey, which I know is quite a popular tool of showing people how you can break out from the mouse and keyboard and create new kinds of like musical instruments. So we had things like a tray. At the time, you had to hold onto the ground and make the connection. So we thought we'd do this through a tray, and you put the items on the tray to trigger notes all around the studio. So very immersive. This young lady, I didn't see her engage with anything else all year other than this musical tray. So it was really fantastic that she really enjoyed this, and it just showed getting that one thing that really gets somebody going is really important. And it takes some weird things like kiwis on an electrical wire to do that, but it did the trick anyway. And we'd have things like bowls that would be wireless with RFID tags and put objects in, and it would change the sounds in the room. So we tried all sorts of things in the studio. And it made me see the problems that technology had in this setting, that it was deemed as too time consuming to learn, a bit of a black box or a bomb. If it went wrong, people got a bit afraid of what to do next. Things were often quite costly. Unless we made them in-house, then you know, you could buy a switch on a cable and it could be £100. It was just a simple switch. So it was there were some problems there. But I saw that when we use technology in certain ways with certain people and we get that right, there is something magical that can be had there from the use of these tools. So I went back to university for my final year and I did a project called the Sense Egg, where I made a wireless controller. In the wireless controller was an arcade button, a distance sensor, a slider, an accelerometer, and the little one on the bottom left there is a wind sensor, which originally was in its mouth, but it interfered with the distance. So I had to put it in its bottom, which was the cause of lots of laughter from the kids. And I streamed this data that was all these data streams that were coming from this egg into MaxMSP to create some sort of controls and some sounds that would come out. So I had things like triggering different animals on the farm and triggering a different patch for triggering the drum set and a different patch for making a kind of theremin affair. And basically it was about engaging children and young people with kind of musical concepts through this bespoke novel controller. And I made it so that it would communicate with the iPad to ensure that people that were supporting these young people would be able to control it, really, because they wouldn't want to go up to a computer and mess about with that when they've got the child right there. A lot of times in these settings, computers would get in the way or cause a distraction for the kids that they were working with. So the iPad was a bit of a fundamental link there. And this led into my doctoral research, my engineering doctorate, which was also at Bournemouth University, EPSRC-funded. And that was to look at using technology to support the facilitation of music making. So it's a bit more one away from looking at the individual, but looking at those that work with them to give them tools to help facilitate it. The fields, I think everybody here will probably be familiar with these fields of human-computer interaction. Participatory design was in there, and this sort of idea of user-centered design. The humans that I was looking at was those that may be physically impaired, they may have cognitive learning difficulties, they may be neurodivergent. There were all sorts of children that we worked with at the school, but also the people that facilitate them. There was those to consider as well. So it's a bit more holistic. The computers that I used, as you've seen, kind of Arduino is my favorite tool with different types of sensors running into MaxMSP usually. And that interaction, the mediation where the technology is mediating this place in between. I love this picture and it's in my slides and I can't take it out, but it's quite old now. It's how the computer sees us, sort of in an eye go. It's a big finger in an eye. I think that has definitely changed now with smartphones and screens that we touch. But it's just that notion of with this type of physical computing. I've got this quote because it kind of sums it up. A lot of beginning computer interface design instruction takes the computer hardware for given, namely that there's a keyboard, a screen, perhaps speakers and a mouse. In physical computing, we take the human body as a given and attempt to design within the limits of its expression. So that's really where I am with my work. It's about the human being. If they can move in a certain way or do a certain thing, then we use that as the control mechanism. It's grounded in the social model of disability as opposed to the medical model. It's very strength-based. So we're not pathologizing the individual, but we're saying what barriers can we remove to enable this person to be who they need to be to get to this musical place that they want to be in. So yeah, it's not about finding a cure or something like that. It's about seeing what we can do to support. And the things that are already in kind of computer interaction and in the SEN setting are these tools that may be familiar to some of you, things like the SCOOG, different types of switches. So I wanted to hone in on what was already in use and kind of work within that as well and explore that. But then to create these bespoke systems around some of those fundamentals as well. So using Arduino, using controllers that already exist. The leap motion's on there, but I did not use that. It's quite an old slide now, so I need to update that really. So I was looking at these barriers to use and these gaps in provision mainly. I don't need to explain to this crowd why it was important to use music. We all know it's non-verbal, non-lingual, it's linked to all areas of the brain. You're involved with sound and music from the womb. It's an extremely powerful tool, as we all know. I'm preaching to the converted here, I think. and it's about building new tools as well. Again, I'm preaching to the converted, because we know about breaking down those the links between a physical instrument and what it can do, and decoupling that from how we control those sounds, which we can do with the computer now. So, but to get in the field, to be able to actually liaise with people and see how we could work together, I used a methodology called action research, which was a very participatory process. It was about developing practical knowing. It was about having periods of action and reflection. And it was about focusing on human flourishing. So putting something in place that was an improvement on what was there before. And that's from the Reason and Bradbury's Handbook on Action Research. So it was quite akin to a kind of product design process of iterating around anyway with action and reflection. These are my aims of my research. So I was looking at incorporating music technology into practices, what issues are around that people have around that, creating new instruments, new tools, assessing the effectiveness of these tools, and then looking at ways of propagating that to spread out to other people. So other people in sort of hack space and more open source philosophies of how to spread these things around and transfer those. In terms of stakeholders, I had 4 research sites. So I had interacted with 3 special educational needs schools, 1 day centre, 20 stakeholders in action research. I call them stakeholders, participants, if you like, 11 staff and 9 children and young people. And I did 4 cycles of this action research. So I looked at the current existing tech. I designed a couple of tools. I designed another tool, and those two things sort of fed back and forward into each other. And then I designed a final tool and integrated that into the toolkit. So the methods, this is a bit academic-y, but I think it's quite good to have in here if people are doing this kind of the more academic side. I used interviews, I talked about issues, and I used the prototype. So I had times where I just spoke to the music therapist. It was just me and them speaking, and then other times I'd bring prototypes and test them out. I did focus groups about the issues, and we used prototypes and tested them out. And I did some things with existing tech. You can see there I've got iPads attached to amps with different interfaces drawn in Beat Surfer and things like that. Or I made my own tech and brought it in. And I made observations. So I watched music therapists when they delivered their usual session without technology. And then I watched them doing some sessions with technology to try and draw out some themes that fed back into my designs. I've got this kind of bit Art Deco looking diagram about the process of working in action research, of developing the technology, and then of forging this into the thesis at the end. But really, this is obviously, we all know more what it looks like to do research. It was a bit of a squiggle that I then things emerged out of. So I like the design squiggle better. And what came out was the MAMI Tech Toolkit. The title of my thesis was MAMI Tech Toolkit, utilizing action research to develop a technological toolkit to facilitate access to music making. They're my supervisors and my mentor, and I was very fortunate to have Professor Mick Grierson as my examiner, who's great, amazing person. And throughout the final, to get to that final point, I developed lots of prototypes along the way, which I took into the school to show people. Probably not appropriate. The first ones were in cigar boxes. You know, I was working with children, but it was fine. There was no cigars in there as well. And we sort of made designs. We saw what worked, what didn't work. We batted around ideas, and we used the tools as sort of anchors to try and draw out what the next step could be. We used them as talking points, and we just generally saw which technology facilitated the active music making we wanted to get to, and what kind of things people wanted to have in the system, which is often very different from what you want to put in the system yourself, which is the good thing and the bad thing about including people in most of the steps. So the final kit, let me go back slightly. So the filter box was the first, one of the first 2 tools that came out. This was a handheld box with a pressure sensor on the outside, a lid, and inside part of the lid was a light dependent resistor. And there were 2 buttons on the side, which you can see here, valve style buttons. And if you wanted to read the thesis for some nighttime reading, there is links to where these kind of design considerations and the features that we put in there, where they came from. So things like the buttons is akin to the kind of valves on a trumpet. The opening the box is kind of, we wanted to go for like a kind of DJ scratching feel, or the kind of intimate, like looking into something. So there's some philosophies behind there about interaction that are weaved in. The squishy drum was again handheld with a squishy silicon surface, had 3 force sensitive resistors in there and a piezo inside, so it could detect knocks. The noodler, you might recognize this as a WeChuck controller, and you would be right, because it is that, but that is such a good little ergonomic, lightweight controller that has 2 buttons, XY joystick, and an accelerometer inside. So lots of data ready in a very cheap package. And then I just basically made it wireless and patched to split the data back out again. And then the touch box, one of the biggest requests was not to be connected to the computer, but to have something that you could just turn on, and it's its own standalone thing. So I've got this touch box that had the teensy board inside with the audio adapter, built-in speaker, headphone jack, screen on there. All the buttons to control it are on the top. They're all different colors and styles, so you can feel what you might want to change if you get used to what shaped dial changes what. 8 detachable pads, and you could stretch them to different lengths of contact copper plate, so touch-based pads, and mounting sockets on the back, so we could screw them to mounts and things, and you could plug them in and out. And they controlled notes in a scale, and you could select the scale and the tonic note, and if you wanted to go up and down an octave. And then we had 4 waveforms as well on there, so you could have a sine wave or a sawtooth or triangle to change the timbre a little bit as well, and the duration. So you can have some nice long traily notes, or you could have some real short staccato notes on there. So that was the final tool in the kit. In terms of the software, the 3 instruments that had to be connected to the computer, we had some VSTs for the filter box, so that plumbed into existing VST architecture, normal plugins that you would use, and you could load those in. I gave a set of free VSTs in there, so it was we had lots of requests for grown-up sounds, so that's what we went for, those real high quality. MIDI is amazing, but to go away from MIDI and get that real high quality that we can have now with those kind of VSTs. Sample triggering was on the squishy drum, so you'd be able to record a sample and then re-trigger it. And the squishy shaker was just sort of physical modeling of shaker sounds that was in there. I feel I could have done more with this element if I would have had more time, but resources were short. So, and then the noodler was up here. It's absolute GUI gore here, so apologies to any designers in the room. But this part was where you could draw the trigger zones. So if a child could move a particular way with the joystick, then we would be able to put a trigger zone in positions where they could play something from their own movements. So it was drawing in those, and then it was attaching the different colored zones. You could have up to 16 colors to either MIDI notes or to different sounds from a sound file. They could drag and drop a folder in. So we had that there. One of the most amazing things was a young person who didn't really interact with the music therapist very much, but in this one session, she had the noodler, and she had her favorite song on there, which was Mamma Mia, and the 2 buttons on the WeChuck controller were just the starting notes of Mamma Mia, and the music therapist was playing what she was playing, and she was playing it back to him. So they had this real back and forth, as you'd expect when you're playing music with someone, and she was very happy, laughing. And the staff said that they'd never seen her laugh like that. So that was just one of the most touching moments of the research, was watching her perform with the noodler. So that was very fun. I've got a little video now of the elements of the kit. 5 minutes, good. I think this is like 2.5 of those 5 minutes. So I'm going to press play so you can see it in action. Okay. Let me know if the sound's not there. It doesn't come straight away.
Fetch thee, London's burning, fire, fire, pour on war.
Okay, so that's the demo of the kit. 2 minutes. So we'll do that again. So the idea was that there was this shelf to shelf. So I put the kit in a box, and the box had the instructions and all the connections and all the cables. In a school, things just disappear or just get splayed out everywhere. And this is a very good containment system. So I went for the kind of flight case feel. So it feel like you were bringing in the kit. It was an important piece of kit. And some really general findings were that when we design around specific users' needs, there's kind of trickle down effect that helps other people that you wouldn't necessarily know about. Contextual factors seem to have a large influence over the continued use of the tech. So I tried to merge these into the designs, things like shelf to shelf and thinking of the facilitators. Action research was great as a methodology because it allowed me to expand the stakeholders as needed. So I sort of brought more people in as I went through, which was really useful. Taking stakeholders out of their systems to give them space to explore the issues was really useful. And using prototypes as probed worked to elicit the next possible iterations and to highlight problems that were going on with that current thing as well. And more specific ones are in the thesis. If you want to go and have a look, then you can choose your flavor as what you're interested in. But there's some more findings in there. And then these are the various spots for dissemination that I delivered, papers that have come out of the research or about the actual instruments themselves. There is a GitHub in which there are the code, all the bits of code, all the Arduino bits, all the MaximSP bits, the final applications, because I exported them as applications for MaximSP for Windows and Mac, and sort of fritzing diagrams of the circuitry, whatever else you might need to try and put them together yourself. Haven't put the CAD files on there yet because people might want to design them in different ways. So that is on there. That was me. Thank you very much for listening, everybody. And yeah, if you've got any questions or if you want to contact me about anything to do with any of it, please do. There's my email address. But yeah, any questions?
Thanks, Asha. Yeah, and I have a couple of questions, but I'll just hang on a minute to see if there's others from the room. So you can either put your hand up in Zoom or post it in the chat if you prefer, and I can pass them on. Okay, I'm going to abuse chair's privilege and ask you one. Oh, sorry, say that again?
No, I said, is it hay bales now or people typing?
Could be. I was just going to ask about the trickle, that's a dirty word now, trickle down effect that you mentioned. And if you could give a specific example of that. So where I think you said that you design for very specific users, but these things generalize more than you might expect. Is that right? Yeah,
so things like what sprang to mind is with the joystick. You know, I was thinking of people using it if they can't move their thumb very much, but actually what happened is the young girl that played Mamma Mia, she used the front of it to play the buttons, but then she would use her mouth with the joystick. So I didn't imagine that, but then I thought to myself, actually she could have moved it on, you held it in her hand and moved it around her face, or other people might have pushed it onto themselves to use it as a controller. So I think I designed it to be like for a thumb, but I just did not think that people would use it in another way and do it like that. And the same with the squishy drum. So I thought about people pressing it, that's what I would do. But actually we had people sort of like leaning on it and putting their head on it. And yeah, so that's sort of, I don't know if that's trickled down, but that's what springs to mind.
Thanks. I'm just picking up a question in the chat from John. How much support was needed to use the MAMI tools? Did your participants require one-to-one scaffolding?
Yeah, yes. So I had to set the tools up throughout the research. The kits, the final form of the kit with the applications and in the box, I still need to I was going to make 5 and give them out to the different settings that had been involved. So that still needs to be done. I've got all the components and the kits are half finished. And COVID came and then I finished the research and I got another job. You know, everything goes out of the window once you've left the real hardcoreness of the doctorate. So I still do need to let people have them, but they were in a place where I could hand over the box. And there was a manual with it. So I was hoping that will definitely be the next stage. But it was scaffolded in that I set it up while I was there, but I did hand the reins of the iPad over to some of the facilitators to control the settings whilst we're in the session together. So it was a bit of A and a bit of B.
Thanks. Yeah, it was really good to see it in the box. That made it look like it was a thing that could go into the world by itself to some extent.
Yeah, a little bit. Yeah.
Another question in the chat from Andrea. So you mentioned learning impairment, and I'm now also working with a floor projected series of sound-based mini games for visual impairment therapy. Have you considered any other impairment, is the question.
So yeah, so we sort of worked with children with learning difficulties, and we did the thing of kind of scaffolding things so that what they were playing would sound right all the time, whether that's right or wrong. We would match in with what the music therapist was doing. If he was doing a particular song, then we'd set the noodler to only trigger notes that were in that song. So we did sort of, we did that. The other thing was with visual impairment, the things like the touch box, we use different styles of knob casing on the dials, so different form factors of the dials, so that people could hopefully feel their way to the control that they wanted to get to. So the decay length had a bit jutting out the side, like the chicken, I think it's chicken head, isn't it? Chicken head cover on it, so you could feel it. And then physical disabilities, I was always considering that in basically the idea of taking a small movement and translating it into a magnified sound. Or if people only had large gross physical movements and couldn't do fine motor control, then to try and use some of that, which was the sort of squishy drum idea, was that you didn't have to have real fine control, you could push around on there. Yeah. Does that cover that, Andrea? If not, you'll have to put it in the chat.
It does, thank you.
Oh, thank you.
Time for one more question, which has also come into the chat. Did you have to do many iterations of the hardware? Was it robust? That's from Joe Timoney.
Yeah, I think the final architecture of it was robust. I did do a few iterations, and I tried a few failed technological pathways, such as Bluetooth, which didn't really work very well. I didn't use Bluetooth Lite or Bluetooth 5, Bluetooth 2.0. Bluetooth kind of failed. So we went with NRF radios, which are like little radios. You have to have a transmitter and a receiver. So that connection was really robust, because once those libraries once the Arduinos were programmed, then that was its own little infrastructure, and you didn't have to rely on updates, or, you know, that was set now as a thing. The hardware was Arduino and my soldering, so, you know, theoretically it was robust. I think that can always be improved in terms of specifically the children that we were working with might not be very kind to it sometimes, or they might tend to throw things, or, you know, things can get in any setting where there's children playing with things, they're going to be the best things to test robustness. So I think there was always scope for more iteration, but the idea was that I would try and test it all to the point where we were pretty sure that it was going to work, because these kids, a lot of them have had so many things fail for them that it's a kind of learned helplessness, where if something fails, they think, oh, that's my fault, I obviously didn't do that right, or, you know. So it was really important to make sure they were robust enough to do what they were supposed to do as much as was possible. But yeah, if anybody wants to, we'll have to send the stuff out and you can try one. I need musicians to try them as well, I think. So yeah, people contact me if you want to have a go.
So just a comment, not a question. I think it's a wonderful example of doing the bottom-up engagement seriously, you know, of really seriously engaging with your end users. You know, I'm very impressed by that. It's great.
Thank you. Thank you very much.
We should probably pass on to Oliver then.